So here we are in Fusion. I like to use Fusion, even though I'm creating something that really is cut on 2 axes. But it's nice to sort of think in 3D. So we're going to be making the 0 clearance plate for the sawstop. So first thing I'm going to do is import a canvas, which is a picture that I've taken at the bottom. And you drag it around. So next thing we're going to do is to calibrate it. And I measured the distance between these sides here. So try and get as close as possible. Looks pretty good. And I know this is 20.57 mil. Maybe a bit lopsided, but that's alright. Let's just blow it up. What do I do? You edit. That looks pretty good. So next thing we do is just create a component. Let's make this a little bit more visible. Maybe. Alright. Let me create a sketch on this plane. I'm going to start with a rectangle. I'm going to come in and get this pretty accurate. About there, you can see that the existing sawstop insert has this metal band which comes around the front. It kind of secures the fit once you put it in. Obviously this won't have that, but we have to take it into account. Let me drag it. There. That's pretty good. We don't want it to be super tight, but I guess we want it to be enough that it's not gonna fly off. The blade skims it. I can't even make out that edge. Looks pretty close. Pretty close too. Alright. So I'm going to bring in these curves. And oh, that looks pretty nice. Alright, keep that 57.5. same thing all around. And this is the top piece, so we're not going to have all of these underside bits. So I'm going to cut this out of 6mm MDF. But we do want this bit here to carry all the way through, so we've got something to grab and pull out. Something like that. That looks pretty nice. Alright, what else do we want here? So, if you're doing it for the dado stack, then it is not necessary to cut a groove in the top for the blade, for the blade. But if you're doing it for the regular blade, where you will have a riving knife in there, obviously if you elevate the blade through it, the riving knife's not going to cut. So you would need to make an opening for that. So this is the back, so that's where the riving knife would be entering. I want to give it some clearance. I don't want to give it a huge amount of clearance. As in, I want the blade to cut through the wood to make a nice fit. But let's give... If I was smart, I would have measured this. But let's give it some clearance. It'd be nice if we could see the picture a bit clearer. If there's a way of doing that, let me know. I'll bring it up to... And we know that the blade's going to be... So that's going to be like the center of the blade. So I think this cutout here is for the... like the bolt or the arbor with the nut on it. So that should be the center of the blade there. And the riving knife, I'm just gonna guess this maybe comes up. I mean, not quite the center of the blade. Further back, maybe a third. So we'll give it a bit of room there. I mean, I don't mind cuttings done up here, so it probably doesn't matter too much. It mainly just matters that we clear it. So we give it a bit of room. I guess the other issue that you're going to find with this, if you are using it with a regular blade, when I initially made this, I just made it for the dado stack. But if you are using the regular blade in there, then if you're cutting... If you're going to tilt it, then that's going to be a thing in itself. I don't know, we'll see. We'll see. I'm really just making this for the dado stack. I mean, I already have this one for the regular blade. But I just thought for the purposes of this video, I include a slot for the riving knife. Alright, we'll go with that. And come down here and just bring that. Don't drag this point. Ugh. Alright, don't want that. It's just, oh, no, it rides on, okay. Alright, my naivety to Fusion 360 is really showing. Let's just cancel that because we like that, and we'll just put another line down here. And we can trim that bit off. Good. Is there anything else we need to include on the top? I don't think so. So I'm going to go finish sketch, extrude it again because I'm cutting on 2 axes with the laser. That so it doesn't really matter if I extrude it, but we will. Just give us an idea. So that's that. And then next we're going to create another component. And we can, oh no, we still need the image for these bits. So we're going to create a new sketch on this plane. Okay. Oh, can we tell? Yeah, there we go. I was just making sure that the plane wasn't existing kind of behind the component we've already drawn. Alright. Create, include geometry. So we want this to be an exact copy of the shape, because the shape is right and we want it to all match up. That's a little nub. And we're going to include all these things because we're going to project them all the way through. In this. Alright. To include that stuff, so now we can just, oh, did I press something there? No. Okay. So we included that stuff. So now we can go ahead and hide the other component. Just makes this underside a bit clearer. Now, and the great thing about Fusion is you usually just draw arbitrarily and then go and clean it up. And see how close I got. Looks a little lopsided, but that's alright. We'll split the difference on that one. Yeah, somewhere in there. I don't think the tolerances are particularly high. So near enough is probably good enough. Try and match these curves. Oh. I mean, that bit's annoying, but isn't that satisfying? Is it? Well, pretty good. I should just keep the same. It was like 7. Oh, there's 6 up there. 6. Yeah, let's keep. We don't want mismatched curves. There. Trim this. Oh, 6, 6, and 6. Yeah, what was it? And that one's 7. And 7. Get rid of that. Alright, there's that. Nine. Ooh. Yeah. Get this. Again, I don't think the tolerances on the sawstop insert has to be that good, but we want it pretty close. If anything, it looks nicer. Like that. I'm going to match these little side bits. It looks like it comes out to there. Maybe lower. So I gotta get the arc to go around there. Let's just do like that. The bottom looking pretty close. Match this. That one's not quite matched, is it? I could just grab, so yank it a little bit. What's it doing up there? That's pretty good. We'll trim all the shit we don't want. Just bring that all the way to there, I guess. Oh, oops. Yeah, so it's figuring out what I'm doing, maybe. Do the same on this side. Nope. It is learning. Oh, no, we don't want those the same. Is it gonna? Oh, it is gonna change that one as well. Alright. Escape out of that one. You put a 6mm on that side and a 5mm on. I don't know, maybe it's the way I took the photo. Who knows? We'll find out. Well, that's looking pretty good. So we've got that bit, that bit, that bit. The blade, we'll cut the rest of that bit. And we've got a spot there for the riving knife to come through. That's there. We'll cut around. You would need that line doing because that one sort of connects to that, and so we'll cut around like that. So you can probably just snip that away. Maybe I'll regret that later. Alright, well that's looking pretty good. So you can finish that. You extrude. Now the actual plate is about 16 mil. I'll be cutting this out of 6 mil. Therefore, I'll need 3 layers, and then I'll just run it through the planer to get the final thickness. But for the purposes of visualization, 16 by 6 will be 10. So let's make this 10 mils. And then we can turn off the image, turn back on the other component, and let's view it all together. Remove that grid for visual appeal. There you go. So, to actually cut this, I've got the shape origin exporter. I don't have a shape origin, but this is a nifty little tool for Fusion if you're laser cutting. So it allows you to export from the free version of Fusion. I think if you pay for Fusion, you can do just about anything you want, but for the free non-commercial version, you'll want to get this to be able to export in the correct file format. And so we're going to go faces. So we've got the bottom face. Okay. Bottom. And the top face. Oh, actually, what I do want to do is put some little alignment holes in it, and I'm going to use 10 mil dominoes to align it. So I'm going to make some holes for those to go in. So I'm going to start a sketch. Doesn't matter which component you're in at the moment to start this sketch. We're just going to pick some spots to do some holes. Center. We know that on the tight setting, the domino will do 13 mil centers. 9 degrees, yes. Yes. Alright, and we're using the 10 mil domino, so 10. And we're gonna repeat that over here. Right, 13. Yes, yes. 10. And one more time. 13. Yes, yes. 10. Cool. Now we're going to finish that. I'm going to extrude this. Why can't I select it? Oh, have I fucked up the plane? I fucked up the plane. What are these little nubs? Hang on. Let's go back. Just sketch. Have I done? Oh, yes. Let's see. Finish the sketch. We're going to extrude. No, still can't get it. Alright. We're going back. This is user error. So we're going to try that again. Create the sketch. Create it on that surface. So where did that put that? Yeah, put it on the front surface. Alright. it doesn't matter which surface you place this on, because we're going to cut through anyway. That looks better. And repeat that. No, I'm gonna put one next to it. A little bit. Don't want it exactly aligned. And put one down here. You could put as many of these as you want there. Alright. Now this should work. We've finished that. Oh, that's looking much better than that. Oh, what happened before? It must have been something to do with the plane. I screwed that. And that. And you. Go through. Cut all. Good. Alright. So it gives us 3 alignment slots, which helps with gluing it together. Cool. Alright. So now we go back to our export to origin. Faces. This one is the bottom face. Alright, so that's that. Now what I'm going to do, so I'm going to bring it into my laser cutter. So we want top. We want one of these. That's good. Bottom. And we want 2 of these. Right. You see, when you do faces, it brings it out in this solid mass, which is not what we want. We just want to get the vectors out of there. So we're going to disassemble. Yes. We're going to take away the infill. And there we go. Same with this. Disassemble. Take away the infill. Disassemble. Take away the infill. And then we've about ready to cut. So obviously that's going to come out at 18 mil, and we're going to take it back on the planer to the exact thickness. In terms of power, I'm cutting 6 mil MDF, 75%. We have 4, and that's ready to cut. And the roving knife is blocking it. I think I've got it flipped around here, but it still wouldn't have cleared that slot that we cut. So we got to go back to Fusion, make a few changes, and this is the result. So I just extended that slot all the way back, so the knife could get through. Just putting together the CA glue here, you can see the dominoes registering it. well. If I was doing this a bit more solidly, I would use wood glue, but just testing a fit here. And planing down to 15.4 millimeters to achieve a nice flush fit there. To achieve that zero clearance, bringing the blade up through the insert. And just checking it's not going to be any interference when I reinsert it. And it looks pretty good. So we can go ahead and make a test cut. Now I know I'm using a crosscut blade here. It's just what I happen to have in the saw at the time. We see a nice edge. Whether that's the crosscut blade or whether that's the zero clearance, I don't know. But it works. So these files will be available. I'll leave the link in the description below. See you later.